Solar cell. Welcome to D Creations Resources. So, solar cell, there's another name for it, photovoltaic cell, or in an abbreviation, it's also called PV cell. It's basically an electrical device, and that device, as the name suggests, converts the energy from sunlight into electrical energy using the photovoltaic effect. So, to think in terms of electronics, it's a PN junction diode, and you can say that solar cells are a form of photoelectric cell whose electric characteristics, say current, resistance, voltage, etc., depend on light. So, the characteristics will vary when the solar cell is exposed to light. Now, of course, when you use them combined, it is used as solar panels. So, several solar cells together form a solar panel, and a common single junction silicon solar cell, if you consider it, it produces a maximum open circuit voltage of around 0.5 to 0.6 volt. But when you have a solar panel, when many of them are together, obviously a large amount of energy can be generated. Now, if you recall the construction of a typical or conventional PN junction diode, there's a slight difference here when we talk about solar cell. A very thin layer of p-type semiconductor is grown on a relatively thicker n-type semiconductor. So, the n-type semiconductor part, that has a thicker layer as compared to p-type, and then some electrodes are applied on the top of the p-type semiconductor layer. So, you can imagine there's a n-type semiconductor layer, thicker one, on which there's a p-type semiconductor layer, and electrodes are applied on that. Now, these electrodes don't obstruct light. So, the light easily reaches the thin p-type layer, and of course, since the n-type layer is below that, there's a PN junction formation there. Of course, when you want to collect current, you need electrodes at the bottom of the n-type layer, and this whole assembly is going to be encapsulated in thin glass so that it gets protected from any kind of mechanical shock, etc. So, when sunlight will fall on the solar cell, the light will reach the PN junction, the photons will be able to enter in the junction because the p-type layer is very thin, and these photons, they have their own energy and they supply that energy to the junction so that a number of electron hole pairs will be created in the junction. Now, the incident light basically breaks the thermal equilibrium condition of the junction. So, the free electrons in the depletion region can come to the n-type side of the junction very quickly. Now, similar case is going to happen in case of holes. The holes in the depletion layer can quickly come to the p-type side of the junction. So, once the newly created free electrons go to the n-type side, they can't further cross the junction because there is a barrier potential of the junction. And same goes for the holes as well. Now, as the concentration of electrons becomes higher in one side, that means the n-type side of the junction, and concentration of holes will become more in the p-type side, the PN junction is going to behave like a battery. A voltage is set up which is called photovoltage, and now if you connect a small load across the junction, there will be tiny current that is going to flow through it. Now, there are some important parameters when you talk about the IV characteristics of the photovoltaic cell, such as there is open circuit voltage. So basically, if you look at the graph, you will see that it is going to be on the x-axis because there the current is 0. There's short circuit current. Now since short circuit is there, voltage is going to be 0. So the short circuit current, the value you are going to be able to find it out as the point will lie on the y-axis. And the criteria based on which the materials are chosen for solar cell, of course, are the band gap. So the optical absorption, electrical conductivity, and of course from the practical point of view, the availability of the material. So depending on that, typically silicon is used, but nowadays compound semiconductors such as gallium arsenide, CDT, etc. are also used. There are some ternary, quaternary compound semiconductors as well. Now, this solar cell can be used for various purposes. It can be used in light meters, or you must have seen it in calculators and wristwatches, and even for charging batteries. And the prime use that was there in the earlier ages was especially the use in spacecrafts. So this solar cell, of course, for like every device, it will have its own advantages and disadvantages. So advantages, of course, the lack of pollution, and that it lasts for a long time. There's not much of a maintenance cost, etc. And of course, it is based on a renewable source of energy, that is solar energy. But there will definitely be some disadvantages, especially when the technology is new. The efficiency is going to be low. There will be high cost of installation, and say on a cloudy day, the energy can't be produced because solar energy essentially depends on the sun. But as compared to these disadvantages, the advantages are much effective. And so solar cell is very important device, not only from the point of view of science and social aspects, but also from the point of view of economics.